Alright, soon let us start today's lecture, that is part 2 of differential equation, and by today we'll finish differential equation. I hope the differential equation 1 was clear to you, where we did till homogeneous equation, and today's class we'll start with the linear differential equation. So the target of today's particular class would be to finish LD, exact forms and orthogonal trajectories. Though we intended to do some questions based on geometrical properties also, but we have already covered geometrical properties in the topic AOD, so just go and revise AOD where we did tangents and normal, that is subtangents and subnormal. So that is the geometrical part of this particular topic. So we'll be focusing on these three, and these three topics are really very important as per say your entrance examinations. So let's start with LDE first. So all of you know that LD, if I talk about the LD part, let me just, yes. So LD is dy by dx plus py is equal to q. So dy by dx, that is the derivative portion, plus py is equal to q if it is differential in terms of y, right? Differential is in dy by dx. Okay, so here what you people have to note is that p and q, which are your two functions here, p and q are functions of x, right? They are functions of x and not, let me just, yeah, it is disturbing again and again. Yeah, so they are functions of x and not functions of y. So rather than saying functions of x, we should remember that they are not functions of y. So p and q here must belong to what? Either constant, they could both be constant, that is not a problem, or they could be function of x. In a way, you remember that they should not be function, they should not be function of y. That is the major criteria that is there with us, right? And then there is a term called integrating factor, which I call IF, integrating factor, which is e raised to power pd integral of p dx, right? Where p is the coefficient of y here. Okay, so remember dy, so here y will come and p and q will not be in y, they will only be in terms of, then yes, so the answer to this problem, that is the solution. So if you are given this, then the solution can be directly written as y into integrating factor, q into integrating factor, and integrated again, plus c, right? This is the answer we are looking for. The proof is very simple, but we are not going to get into the proof. Let's immediately see how we apply this in the problems. Okay, let's take this as the first problem. It is given that 1 plus x cube dy by dx plus 6x square y is equal to 1 plus x square, right? Okay, so this is given now. So if this is given, so what we can say here, let's see. So dy by dx is here. Let's first of all try and make this into dy by basically into LDE form. What is the LDE form? So LDE form is where dy by dx is there plus py is equal to q is there. So we want to arrange this into this form, where if you can notice here the coefficient of dy by dx is 1, so it should be 1 here, whereas here it is not 1. So we'll try and form this to be equal to 1, right? So how we can do so is that okay, let me just make it plus only here. Okay, so if I take it plus, so then it would become what? Okay, so this is then have to be arranged in this particular format. So for the format part, what we will do then, let's divide it by the coefficient of, yes, that is the coefficient of dy by dx. So this is what we can say. Now can you see what is the value of p here? P is 6x square upon 1 plus x cube, and q is 1 plus x square upon 1 plus x cube. So notice p and q were to be functions of x only, which is happening here, so no problems at all. So let us just quickly calculate what are the integrating, what is the integrating factor here. So for integrating factor, you can solve always separately. IF is nothing but e raised to power p dx. Here what is the value of p? P is coming out to be 6x square upon 1 plus x cube. What is the derivative of x cube? So if I say 1 plus x cube, yes, you can see very easily. This is a very simple integration that I have taken. So this is nothing but this. So this is twice. So in fact, integral will be 2 times ln 1 plus x cube, right? We do not generally write c here, so you should have asked that, sir, we should have written c here, but notice for integrating factor we skip this c here, so we do not write this c here. Okay, so and we want this 2 to come inside, so I can say e ln 1 plus x cube whole square. Now since you know the formula that this is base e here, so this formula is something like this: a log b with base a is nothing but b, right? We did this in integration as well. So sorry, in differentiation topic. So this becomes 1 plus x cube square. So this is the integrating factor. So then what will be the answer? Answer is given by y into integrating factor. Integral of q into integrating factor dx and plus c. So y into integrating factor is 1 plus, right? Now integrate q is 1 plus x square by 1 plus x cube into integrating factor is coming out to be what? Yes, integrating factor is 1 plus x cube whole square dx, right? And you can solve very easily this one now. Okay, so this gets cancelled out and you are only left with a very simple calculation here that you want to integrate, and this could be integrated very easily, right? You can just multiply the brackets and solve this. So I hope the concept of how we use basic LDE is clear in this particular question. Now let's take the other problem. It says dy by dx plus y. So it is completely in the form of LDE. LDE says that dy by dx plus py is equal to q, where p should be function of x. So p is, yes, 1 this time round, and q is completely a trigonometric function in terms of x, 1 plus sin x upon 1 plus cos x. We know we need to find integrating factor. Integrating factor is e raised to power p dx without the constant part, right? So here it has become e raised to power dx, which is nothing but e raised to power c. Okay, so the integrating factor is also there. So the answer will be y is equal to e raised to power x. Integral of q, what is q? 1 plus sin x upon 1 plus cos x into integrating factor, that is e raised to power x dx. So this is the answer that you have to solve. And in fact, if you see this, this question now completely becomes of integration, right? Yesterday also I was talking about why integration is generally not asked. This is the reason, because in differential equation only we can ask you integration. So why waste another question checking your integration skills? So if you remember how integration of this topic would be done is, there is e raised to power x and some function. So remember the formula that e raised to power fx, e raised to power x, fx plus f dash x integral. The answer to this problem was e raised to power x, fx plus c. So this is what you should actually remember. That is why it is a very important formula, and we'll try to arrange this particular integral in the same format. So if we start doing this, I can say I will split them up. First of all, let's say 1 plus this and sin x by 1 plus cos x, right? This is what I can do. What is the value of 1 plus cos x? 1 plus cos x is nothing but 2 cos square x by 2, and sin x can be written as 2 sin x by 2 cos x by 2. Yes, I hope so. Most of you would have seen why I'm doing so. What's the target behind this? So if you see properly, this becomes what? E raised to power x. This can be written as 1 by 2 secant square x by 2. One of the cos will get cancelled out, 2 get cancelled out. What you are just left with is tan x by 2 dx, right? Clear? So if this is the case, then what would be your answer? Obviously the derivative of tan x by 2 is 1 by 2, so it is completely in this format. So the answer then becomes y e raised to power x is equal to e raised to power x tan x by 2 plus c. So this is the answer you all were trying to find. Okay, again a very basic problem on LD. Let's take the other problem. It says that this is x plus y plus 1. So even if I try and write this in the form of LD, so this is what you will have to do. Now you can see that anyway, whatever you people will do, you will not be able to write something in this format, very obviously, right? Neither this is homogeneous. So there is a confusion between which method to be followed. So it is neither homogeneous. Can you tell me why it is not homogeneous? neither homogeneous, right? And it is nor variable separable at this point of time. Though we can make it variable separable, reducible to variable separable by taking, yes, absolutely right. Some people have rightly pointed out that you can do this particular activity to make it variable separable. So this is a valid step. This is not homogeneous. Why? Because see, degree 1, here degree becomes 0. So all the three terms does not have the same degree. And here again degree on the right hand side on the term is 0. So it is not homogeneous. But I am trying here to explain it to you not by the reducible to variable separable, but by taking it as a LDE form. So remember that if I just reciprocate all the terms from LHS and the RHS side, this is what will I obtain. And can I say that it is dx by dy plus, sorry, not the plus sign, now I will have to use minus because I am shifting x. Yes, minus x is equal to y plus 1. Now compare this with this here. It was LD in y. I can say LD in y. Why I am saying LD in y? Because the dependent variable was y. I can similarly say LD in terms of x, which will be dx by dy plus px is equal to q. Now here the condition will change that p and q does not belong to functions of x, or they belong to function of y, or they are constant, right? If this is the case, then the answer to this particular case would be just replace the role of x and y. So if you remember, the answer to this particular problem was y into if is equal to q if dx plus c, right? Now just replace the role of x and y. So this will be x into integrating factor is equal to q into integrating factor, right? And it was dx, now it will become dy plus c, and also the integrating factor will change. So the integrating factor on this side was e raised to power integral of p dx. You were integrating with respect to x because x was in the, you were differentiating with respect to x. Here you are differentiating with respect to y. So similarly, the value of integrating factor will then change to e raised to power p dy. Absolutely. So if you can apply this, this question becomes readily solvable. Why? Because the value of p then will be minus 1, because what is the coefficient of x? Yes, minus 1. So p becomes minus 1. What is the value of q? Q is a function of y, which is y plus 1. Okay, so if you apply this, then what will be the integrating factor of this particular question over here? The integrating factor here will be e raised to power p dy, not p dx. Remember, this is the common error that we do. So it is minus dy, so it returns what? E raised to power minus y only, right? And now if I try and put this into the answer, so this will be x into integrating factor, that is x into e raised to power minus y, is equal to y plus 1 into integrating factor and then the its integral, right? This is how you will solve, and we can solve this now very easily. Can you tell me how you will solve? Yes, obviously we'll take it by part method. So this is your first part and this is your taken as the second part. So integral of this would be what? Y plus 1 into e raised to power minus y by minus 1, that is the integral of the second part, minus derivative of the first, which is 1. We have already taken the integral of this is nothing but y. So the complete answer then I can say will be minus 1. Okay, I hope this step is completely clear to you guys. Okay, so minus e raised to power minus y plus c, right? So the net answer then could be written as that this implies this is equal to x e raised to power minus y. This is what we were trying to solve. Okay, so just remember that as we have done LD in y, we can similarly say LD in terms of x, where dependent variable is x and the independent variable we can make as y. Okay, let's take the other problem then. It says 1 plus y. So again, if you see on the onset, it is not a homogeneous. Here degree is 0, here degree of the variable is 2. So it is not homogeneous at the straight. Even if we try variable separable, it does not look like a variable separable, because here this function here, this particular step is implicit in nature. So that means it has to be solved using LD That's the first hint that I can get from this particular question. So immediately let's try and start forming dy by dx. So if I try and form dy by dx, I will get something like this, right? Okay, and we know that in LD in terms of in y is nothing but dy by dx plus py is equal to q, right? Now can we arrange this in this particular format? Can you tell me? The problem is that we cannot arrange this particular case in this particular format. Why? Because of this particular denominator. So we know that denominator cannot be splitted, right? So we can write this in the form of 1 upon tan inverse y minus x plus y square upon we can write this, that is not a problem. But this does not solve our question. Why? Because see, here both x and y is here. Here also in this term both x and y are here. Now let's try another approach where we'll say dx by dy. If I say dx by dy, that is just you have to do the reciprocal of this particular term over here. So if I do the reciprocal, you will be getting this particular stuff here. And now if you split, now I'm telling you with a very shortcut or a layman definition why it is beneficial. So now if you see this term, yes, is independent of x, right? So this is actually what will work out in our case. So rather than saying LD in y, I'll try and form LD in terms of x, which should be written something like this. So there is a x term here. So that means I will say dx plus dy plus x upon 1 plus y square equal to tan inverse y by 1 plus y square. So now this completely is arranged in LD form, where the value of p is, yes, 1 upon 1 plus y square, and the value of q is tan inverse y upon 1 plus y square. This is the value that you will obtain. And then obviously the integrating factor, since it is LD in terms of x, I'm again repeating, just do not do the error of putting dx here. It will be p dy. So it is dy by 1 upon y square, which is nothing but e raised to power tan inverse y. So we have got the integrating factor. So the answer is x into integrating factor q times integrating factor dy again. So x into e raised to power tan inverse y is equal to q is, yes, tan inverse. I hope the question is clear to you people now. So sometimes it just takes time to arrange the question in the way that will make it easy. So be very spectacle about both of them, whether to form LD in terms of x or to form LD in terms of y. I'm leaving the portion for you guys to solve now, because you just have to take tan inverse y equal to t in this problem to get solved. Because if you take this, what will happen? It will become t e raised to power dt, and then you just have to use by parts to solve this problem. Alright, which I hope you all of you can solve. Now let's take other variety of LD. So at the first step, it looks like an LD in terms of, so it looks like LD in y to you guys, right? LD in terms of y. For that, if you check here, p comes out to be what? X by 1 minus x square. And what is the value of q? Yes, the value is of q is not in terms of x. So here q is not a function of x only, right? It contains y also. So this implies that it is not in LD, right? That is not in LD form, you can say. That's the problem here. So this question is based on the concept which I called as reducible to LD, right? So what do you mean by reducible to LD? Let's see. So the steps that you have to take for reducible to LD is, the first step is remove y terms from RHS, right? So if I take this particular here, this step, if I imply, so the RHS has 1 raised to power y raised to power 1 by 2. So I'll divide by y raised to power 1 by 2 on both these sides. So this is what you will obtain, plus x raised to power 1 minus x square, and this will be y raised to power 1 by 2 because it's already a y here. And now RHS becomes free of, so here RHS becomes free of y. The second step, this function says that make make coefficient of dy by dx, that is dy by dx, free of x. There should be no function or term containing x in front of dy by dx, which is already there with our case, right? There is no. So the third step, important step, is take middle term to be t. Make middle term equal to t. So I'll explain you what is the middle term. So in this particular expression, the p that I talk about, the p is the coefficient of y, right? Here p. So this is called the middle term according to this particular convention. This is the middle term. So you have to assume this equal to t. So let's see, if you assume y raised to power 1 by y is equal to t, now differentiate. So what will be the derivative? 1 by y, yes, right? Dy is equal to, let's say we differentiate with respect to x, is equal to dt by dx. So can you see what benefit we have derived it from here? This complete value, it is here. So it completely gets converted to 2 times dt by dx. This reduces to 1 minus x square times t is equal to x. Now you can actually divide it by 2. So it will be 1 by 2, x by 1 minus x square t is equal to x by 2. And if you now check this particular stuff, so I can say this is LD in terms of, yes, in terms of t and x. Not in terms of y and x as we would have liked, but it becomes LD in terms of t and x, which can be easily solved. So again, the target is to find that integrating factor. So what is the integrating factor that you people can find easily? What is the value of p here? So the p is now 1 by 2 x 1 minus x square, right? So the integrating factor would be what then? E raised to power 1 by 2 x upon 1 minus x square dx. We can easily see, we can again form the derivative form. So the answer to this particular problem would be what? E raised to power minus 1 by 4 ln 1 minus x square, and this is nothing but 1 minus x square raised to power minus 1 by 4. So this is the integrating factor that you will get over here. So we have now got the integrating factor. We just need to solve what? So we are just trying to find the value of, now remember this has now reduced to variable in terms d in terms of t. So the answer to this particular stuff would be then, yes, t into integrating factor is equal to q into integrating factor dx plus c. Remember, it is still in terms of t, not in terms of y. We'll come to that, how we'll convert to t. So you will say t into the integrating factor, that is this particular quantity. Q is nothing but, what is the value of q here? Q is x by 2. So it is x by 2 into 1 minus x square raised to power minus 1 by 4 dx plus c. Right? Now, if you want, you can immediately put the value of t back, because you have substituted t equal to be y raised to power 1 by 2. Put the value here. So this will be reduced to the answer in terms of y and x. For this, I am again leaving the part of indefinite integration. So you will have to solve indefinite integration here. You can solve it. All right, let me just leave it. So you can solve this by assuming this raised to power t raised to power 4. Right? I have given you the hint how to solve this ahead. But understand the concept of reducible to LD. So the steps that you people have to remember is that remove y terms from RHS, make coefficient of dy by dx free of x, and then take middle term to be equal to t. Let's take another question on reducible to LD to understand that concept. So again, it is not straight away LD. Why? Because if I tell you, let's arrange this into the LD form. So you will get something of y cube is equal to x, right? So now again, let's compare it with the normal LD that we people have done, right? Can you compare here that we were having py, that is linear in y, here it is y cube here. So it is first of all not a normal LD. So the first step was, what was the first step? If we remember, make RHS free of, RHS should be free of y terms, right? So RHS is completely free, so this is already done. There is no term of y. Then our second step was coefficient of dy by dx, this should be free of x terms, right? So that is also happening here. That is also not a problem. This is also done. Okay. So now let's, what was the third step? Yes, the third step was let the middle term be equal to t. So what is the middle term here now? Middle term is y cube. Let's assume y cube equal to t here. So if we do this, this becomes 3y square dy by dx is equal to dt by dx. Now can you see that y square dy by dx is already here. So this now question reduces to dt by dx 1 by 3 minus t is equal to x. Now you can say this reduces to LDE in t and x. Again the same stuff. So now this question actually reduces to a very simple problem where you will say it is 3t is equal to 3x. The value of p is minus 3. The value of q is 3x. Integrating factor would be e raised to power p dx. It is e raised to power then minus 3 dx, which is nothing but e raised to power minus 3x. So the net answer then will be what? X into integrating factor, that is minus 3x, is equal to integral of q. Q is 3x, integral of e raised to power, what the answer is for the integrating factor? Minus 3x. That's it. Plus c, right? Yeah, this is the answer. So there is just a small error. This is not yes, x, completely acceptable. This is t here. So you will then replace t as nothing but y cube. So the answer is nothing but y cube into e raised to power minus 3x. And obviously you will have to solve this. And again, you can see that this is a very easy integration, which I hope you people can yourself solve. Just use by parts. Alright, just use by parts to solve this. So my intention was to again solve reducible to LD problem. Reducible to LD. It was not directly in LD, but we reduced it to LD. Alright. Okay, now let's take very interesting problem that is not should be interesting problem, but an interesting concept which is called exact form, and it is basically a trick method. You can understand it as a trick method, alright, of solving questions very quickly. And what is the trick involved in this? Let me now explain it to you. So for example, on the screen, these are the formulas which are generally used. So for example, let's take the first one, x dy plus y dx. So if something of sort x dy plus y dx is given to you, I can actually replace it with d of xy. So what I have done here is called partial differentiation. Remember, we did this earlier also. Partial differentiation. Why? Because I do not know with what respect I am differentiating. So I'll first of all differentiate x keeping y constant, and then I'll differentiate y keeping x constant. So this is what you will obtain. So what happens here is that now rather saying separately y and x, you have differentiated with respect to xy. Now you will look for functions of xy. Don't worry, I'll explain with the help of a question that what do you mean by functions of xy here. Just understand that how we are doing this. Alright. So for example, remember, if x is with y and y with dx, then you will say d of xy. The second is x with x dx plus y dy. Can you see now? So for remembering, what you can do is first of all go through all these formulas from right to left, not from left to right. So for example, if you differentiate this, x square is 2x dx, y square is 2y dy, right? Partial differentiation. So you will get this. Remember, if we want x square in the denominator, right? When do x square comes in denominator? So if I talk about something in the denominator, yes, denominator, by denominator I only can think of quotient rule, right? Quotient rule gives you something square in the denominator, right? So that means I am trying to do something of this sort. So dy by x, if y is in the denominator, and if you try and differentiate this, what will be the answer? X dy minus y dx by x square. That is what is written. If y square is in the denominator, then it will be x by y. If let's say both are in the denominator, so when both can come in the denominator, yes, when it is log there, right? Log y by x or log y by x or log x by y. right? So now how to determine which log will be used? So let's say if I differentiate this, what will be the derivative of this? 1 by x by y into derivative of x by y. What is the derivative of x by y? This is already written here. See, so it becomes y dx minus x dy by y square. So you actually, what you will get is 1 by xy y dx minus x dy. So just see to it, it is written over here. So this is log x by y. This is log x dy. So how do you understand this is? The trick is, if dy is first, y will be above. If dx is first, then x will be above. Okay. What if you want x square plus y square? Yes, we know this x square plus y square comes in the formula of absolutely tan inverse y. Again, if dy is first, y will come in the numerator. If dx is first, then x will come in the numerator. Right? Clear? And if it is plus, so now compare, this is again a beautiful formula. This is minus here, this was plus here. If plus is there, you just use log xy, right? Why? Because log xy will do 1 upon xy, and then you'll differentiate xy by using chain rule. So people who are again still having problems, for this, think of it as a chain rule. So log xy will be differentiated as 1 by xy, and then you will differentiate xy. You have already done this here, remember, right? So, and the third, the last problem that you can do is remember this particular step also. So in fact, what I would say, these are just 10 basic cases. There could be infinite such problems. There could be infinite such cases, right? And we do not have to remember all of them, right? You just have to remember these are the 10 very basic ones which I have taken. These are the basic cases, you can say. There could be anything that you can think of. The only part is the application point of view, how you are going to use it. Okay, I'll show with the help of examples that how exact forms are used in the question and how simple the question then becomes using the exact forms. Okay, now let's take a question which is based on the exact form. So I can see here there is one particular form which I can use, and here there is another particular form which I can use. X dx plus y dy. We did that x and dx, if they are same, I can say this as half d of x square plus y square, right? And what about the next one we just did? When this x square plus y square will come out, yes, it will come in the formula of when we'll differentiate tan inverse y by x or x by y. But since it is dy in the earlier step, so y will come outside. So this can be written completely like this. Remember, I just told you. So it can be written as d of tan inverse y by x is equal to 0. So now this is the problem that you have at hand, and now you want to solve this, right? Just integrate. Very simple. So if you integrate, there is no, so this is what you will be looking for, that you want functions in the terms of x square plus y square, but there is no function ahead. So d and integral will get cancelled out. You will just get this particular quantity here. D and integral will again cancel out. You will get this particular quantity over here, and plus c. This is your answer. That's it. That's the question. And this you can say easily as your answer. This is the beauty of exact form. If you try and start using it, it can greatly reduce your effort. Because just imagine, first of all, you people would have started doing something like this, trying arranging as dy by dx, which is completely lengthy, right? This is, I can say, will again take 3 minutes of yours, and I've actually solved this question within less than a minute's time. All right. Okay, now let's take another question on exact form to understand how this concept is peculiarly used in problems. So for example, here you can see now there is 1 minus x square y square dx, and here it is x y dx and x dy. Y is with dx, x is with dy. So we know that this is nothing but d of xy. This is what we can say about this, right? Let me just write it as normal. So in fact, now I was telling you in the earlier cases that now I have to start searching for a function of xy which is already there. So how I will write this particular question is, I would say d of xy divided by 1 minus x square y square. Why I am writing like this? Because if you say d of xy, so is this function in the denominator is completely a function of xy function, right? You can assume for the timing that this is nothing but dt by 1 minus t square. Can you assume something like this? So it is not a substitution that I have done. It is just for you people to think of it as if that here the role of t is being played by xy, right? So if this is the case, we just need to integrate it. This comes out to be x. We need, what is the formula that we can use? It is 1 by 2 ln modulus 1 minus t by 1 plus t plus c, right? And then you can simply just put the value of t again. So this is nothing but 1 by 2 ln 1 minus xy by 1 plus xy plus c. That's it. Question is over. This is the answer we were looking for. Okay. I hope the question is clear. All right. Yeah, you can just change the formula. Yes. So I've done an error here that yes, minus will come down side. So this is something like this. Okay. So this is the change. So this is the answer we were looking for. Let's take another problem to understand this particular concept. So now this particular problem seems to be a very lengthy problem. Okay. Now how I am going to solve this? Let's see. I'm trying to form pairs. What pairs I can see? There is sine y dx and there is a term for cos, right? So I'll start writing them side by side where they are being used. Okay, so let's say x, this is cos y and this is dy. Okay, can you see now how exact forms are used irrespective of the formulas that we have earlier done? This is the perfect example for this. So if I say, if I want to combine these two, can you say it is here dx? So that means something x has must have been differentiated. Here it is dy and it is also cos y. So when will you get cos y dy? When something of sin y will be differentiated. So if you partially differentiate sin y, so if I say something of d of sin y, so what you will answer? Sir, it is cos y dy, and here it is dx, and you can see here x is also. Can you see this complete term can be written as this combined thing? It is, these two terms are nothing but derivative of x sin y combined, and if you apply the product rule, these are the two terms that you are going to get, right? Now let's take another two terms. So this is the first term and this is the other term, y dx plus x dy. So we know this already, right? This is nothing new to us. So this is nothing but d of xy. So the two terms that are still remaining for you is, one is this particular term and one is the log term. So let's see this. This is y by x dx plus log x dy equal to 0. Now is there something that can combine both these particular expressions? Yes, see how. So it is dx here. So something must have been differentiated here and you will also get denominator x. Hint is given in the next expression, that is log x. So if you differentiate log x, so what will be the derivative of log x? Yes, log x derivative will be 1 by x dx, which you are getting, and there is y. You can just simply state this is nothing but d of y log x. So if you combine the entire thing, it is just this expression. Just see to it. That sin y plus d of y log x equal to 0, and you wanted to find the equation out of this particular thing. Just integrate all of them on both sides. So if you integrate, what we will get, this is xy, this is x sin y, this is y log x plus c equal to 0. This is the answer we were looking for. That simple exact form can make a question. So it looked like a very intimidating problem here. Can you see how simple this question has become now by using exact form? And remember that exact forms are not just meant for the formulas. That is why I said that there are infinite cases which we can make of exact form. So it is up to us that how we utilize the exact form. So for example, these two were not the standard exact forms that we have done, right? This and this. But whereas this one was the exact standard form that we do. Okay, so keep your minds open, be critical at the question that you see. Okay, now let's take another problem to again highlight the exact form usage. So it says dy by dx plus y by x. So the way it is represented, it looks like that it is meant to be in your LDE form, but obviously it is not in the LDE form because the right hand side has implicit function of x and y. So this is not an LDE first of all. Okay, now I can combine the right hand side by saying 1 plus log xy, log a plus log b is, yes, simply. So up till now there is no problem and everybody could understand by this particular step. Now first of all, this is not an LD. Let me explain it to you. So this is not an LD, not a LD problem, right? Because for LD the RHS was function of x only, right? Whereas it is implicit in nature where x and y cannot be separated. So this is not an LD. Now we need to check that what other steps that are there which we can follow. It is not obviously homogeneous because it is y by x, there it is xy. So it is not homogeneous and variable separable it does not looks like at this point of time. So what we can do here is, now let's see. So I cross multiply and what I'll get, x dy plus y dx upon x dx is equal to 1 upon 1 plus log xy square, right? This is what I can write. This is possible, don't worry, this is possible for the first derivative. Had it been the second derivative here, that is dx square, this step is not allowed, okay? But you will not be asked the second derivative because it is not in the course. So if you see, this becomes the question something like this: dx dy, y dx, I can say x dx here, and this is 1 plus log xy whole square, right? And if you check this, we already have done this in the exact form. How I can write this particular step is d of xy, right? And what does d of xy signifies now? That you need a function in terms of xy. And yes, voila, we already are having this, right? So this particular function, the denominator one, is already in terms of x and y. So what I'll do, I'll shift it over here, right? I'll now explain to you how we are going to solve this, right? dxy is equal to x dx. Now you want to solve this only, and now it is completely solvable. Why? Because you just need to integrate this, right? And for this, for the time being, you can just assume that xy again is nothing but t. So you are integrating 1 plus log t whole square dt is equal to, this is already integrable, right? X square by 2 plus c. Got it? And how you are going to solve this particular case now? And yes, obviously, so we will use by parts to solve this particular problem where we'll take this entire as the first part. So the integration of this will be 1 plus log t whole square into integral of 1 dt, that is t, minus derivative of this, that is 2 1 plus log t divided by t and integral this t dt, right? This is nothing but x square by c, 2 plus c we have already calculated. So this is solvable. This t and t gets cancelled out, and the other stuff that is given to you is completely solvable too. Why? Because it is 2 times, this will become 1, integral is t. What is the integral of log? Yes, it is t times log t minus 1, right? This is the answer we are looking for in this particular question. Okay, and now you can just put the value of t back into the question. So the complete answer would be yes in terms of xy. So this will be, sorry, in terms of log, because it is log. So that is how you actually have to solve this problem. I hope it is clear that how we have applied the exact form to actually reduce this problem into a very simple problem. Okay, now you can actually further go on and simplify by taking logs of the same side at same place, but this is the particular answer we are interested in, right? And also I have used this particular, so that is why I am again repeating that we use a lot of integration in this particular chapter. That is why indefinite integration is being specifically asked in questions involving differential equation. Okay, so remember the integral of log t because it helps in speedy calculation, so that you cannot have to apply by parts again in this step. Okay, I hope the concept of exact form is now particularly sure with you. So now let us understand the concept of orthogonal trajectory of a curve. So what is the concept? So I have taken two diagrams and I'll try and understand, I'll try and make sure that you understand the concept using these two diagrams over here. So let's say this is the given curve, right? These are all the given curves. So given curves. Okay, so these are given curves. You need to find a curve, right? Curve which intersects the family of curves given by the D, which family of curves given by D, because a D differential equation will be given to you at 90 degree. As the name suggests, orthogonal. So orthogonal we have done and means 90 degree. So you need an equation of the curve which intersects all these various curves at 90 degree. So this particular line that, or this particular trajectory that I have drawn, this one, right, is known as the orthogonal trajectory because it is intersecting these family of curves at an angle of 90 degree. Okay, clear? So for example, if this is a family of lines which is a concurrent line, right, concurrent lines. So here in this particular example, given DE is given is concurrent lines, right? They are concurrent lines. So all the circles whose are concentric with their point of concurrency. So circles which are drawn with different radius, but their point of the center is point of concurrency. So these circles are now what? Orthogonal trajectories. Why? Why they are orthogonal trajectories? Can you tell me? Yes, very obviously. Why? Because each of these line is now a normal to this particular circle. Why? Because all the normals pass through the center of the circle. So that is why these again become the orthogonal trajectories. So what is the method of finding orthogonal trajectory? So first of all, you have to find, so these two steps are to find given differential equation, right? To find given DE. So for example, you will be given some constraint, find relation. So this is find relation, right? Or you can say the equation where C is the arbitrary constant. Differentiate the equation with respect to X. So this is basically where you will form the DE. So this is nothing but you can say formation of DE. This step is nothing but first two steps are formation of DE from the given constraints. Then the important point is if you want to find the orthogonal trajectory, instead of dy by dx in this particular step, replace it by minus dx by dy. So how you can actually remember this is that what is dy by dx? What do you mean by dy by dx? So dy by dx is nothing but the slope, right? Slope of tangent. And for orthogonal, if they intersect at orthogonally, orthogonal means they are at 90 degree. So the slope relation would be m1 m2 is equal to minus 1. So the slope of the other would be minus 1 by m. So this actually can you see will be what? 1 by dy by dx, which is nothing but minus dx by dy. That is why we are saying that you have to replace it by minus dx by dy. So here this becomes a dE. Now this step becomes what? Finding solution of the dE. So this is actually solution of dE. So actually this particular orthogonal concept involves both the processes, that is formation of DE and solution of DE. So you will form the you will do the formation of DE for the given constraint. You will try to find the solution of DE for the orthogonal trajectory. This is the concept. Okay. Let's take an example to understand how you are going to solve the orthogonal trajectory. So you want to find orthogonal trajectory of the circles which are given by the relation x square plus y square minus ay equal to 0. So how many arbitrary constants are there? So arbitrary constants over here is nothing but equal to 1. That implies order is equal to 1. That means you can differentiate only once. That is what we can say about this. We can differentiate it only once. So let's differentiate it then. So you will, what you will get is 2x plus 2y dy by dx minus a dy by dx, right? This is what you can say. But here still you will get a your target was to eliminate a, right? You wanted to eliminate a, Though you can eliminate a now by putting the value of a back from this particular value over here, right? This is what you can do. So this will be what, 2x plus 2y dy by dx is equal to a times dy by dx, and you can just put the value of a from here. So what is the value of a? Is x square plus y square by y dy by dx. So this is how you can actually remove. So this becomes 2x plus 2y dy by dx is equal to x square plus y square by y dy by dx. This is nothing but 2x is equal to x square plus y square minus 2y by y times dy by dx, right? This is what you will get, and if you combine all of this, what you will end with, it will be x square minus y square by y dy by dx. Okay, this is what you will get. Now this is this step. Up till this step, what you have done, you have formed a DE, but this is for the curve, right? This is for the curve. What you require is orthogonal curves, right? You wanted orthogonal curves. So for orthogonal curves, what we have just studied is that you will replace dy by dx by minus dx by dy. That is what you are going to do in this particular problem. So what this question then will look like is 2x is equal to x square minus y square by y, right? And this will become minus dx by dy. This is what it will become. And if I write dy by dx, so what will be dy by dx in this particular case? It will become y square minus x square by 2xy. And if we see, this is nothing but a equation of the form, it is nothing but homogeneous form. Can you see this? You will just substitute y equal to xv, and then you can easily solve this. I hope the concept is clear. The major thing that we have to understand is the concept, not how we are going to solve it further, right? So if you want to solve this further, this is now completely solvable. How you are going to solve is that v plus x dv by dx, and now this is something what you will call v square minus 1 by 2 v. That is what you will get. I hope this question is clear now. And if you try and solve this further, this is what equation you will get over here, which can be easily simplified by doing something. This dv is equal to minus dx by x, and now you can just simply integrate this, right? You just need to integrate this particular step over here. So if you integrate, what you will get, I am just solving it above here. It is ln 1 plus v square mod, though we do not require a mod sign anymore here, ln mod x plus c, right? This is what you should get here. I told you earlier also that you can also combine c here with, you can write ln c. So this is ln c by modulus x. This is what you will get. So the net answer then should look like something 1 plus v square is equal to c by modulus x, and now you can just put the value of v back. It is 1 by y square by x square is equal to c by modulus x. So this is the answer we were targeting. Okay, but this is how the orthogonal trajectory concept has to be solved. In fact, there might be a question where you will be trying to find a particular solution. So what do you mean by a particular solution? That you need to find the value of c, or you will find an option where the value of c might be given as 5. So answer could be x square plus y square. So an option in the paper could be something like this: x square plus y square by x square equal to, let's say, 5 by modulus x. So this could be an answer, right? Because here the c value is 5. So this is basically a particular solution, and this is what we have got as the general solution. But this is the overall concept of finding orthogonal trajectory. Okay, by this we come to the end of this particular chapter. We need not do more than this particular stuff. And I am again repeating, if you are just targeting the JEE Mains, this is more than sufficient that you can do for differential equation. Otherwise, this topic is completely on a different level if we talk about the JEE Advanced stuff. But since we are just targeting JEE Mains, I suppose this is more than sufficient for you guys. Alright, just completed your NCERT. because that's a very good textbook, as I repeated yesterday as well. And I have sent you the worksheet. Just solve them. I guess this will do your job for the JEE mains. All right. For NCRT, as usual, just go and watch the channel for the video solutions. All right. So I'll see you with the new topic tomorrow. Right. Till then, good night. Keep learning.